Okay, so good morning, everyone. This is the second part of Chapter 5, when we're talking about control structures and repetition, so basically loops. So as a review, the main thing that we were talking about is that we have different kinds of loops, and one of those loops is the counter-controlled. So we use loops when we know exactly the number of counts, how many times the loop needs to iterate. The other consideration we have to control our loop is the sentinel. So with the sentinel, we have a specific character, a specific value that we're looking for in order to stop the loop from executing. And the third way of controlling our loop is with a flag. The flag is usually a Boolean value, and usually it comes from a structure like a file. And in object-oriented programming classes, you'll understand what do you mean by internal structure to a file or to an object. Okay, but just keeping in mind that the flag control is usually a Boolean value. So we talked about the Fibonacci number. So when you have a problem, computer science is about problem solving. So problem solving is basically you need to analyze the problem and then design the algorithm. That's why we have the flowcharts and pseudocode. And then we actually code it. And when we code it, we still gonna make mistakes, syntax mistakes, logical mistakes. And then we correct it. But at least we're gonna have a better understanding how the program's supposed to flow. So we looked at that example with the Fibonacci numbers. So hopefully you guys looked at the example and you guys walked through the whole process of designing this problem. So when we're talking about loop and looping structure, we need to consider in the flowchart shapes when we write in the flowchart and even in the pseudocode the initial statement or the priming value, and then we have the loop condition, and the condition we control by either counter or by sentinel or by a flag. And then we have statements that we accomplish within the loop, and then we need to have the update. The update is supposed to be updating what we did in the initial statement. And that's where you guys had that exercise when you actually looked at a loop, and within the loop we did something, but before the loop, so the loop comes back around, and let's say we did A over here, then we said we also have to do A over here inside the loop before we exit the loop, and then we continue on. Okay, so if we only had, let's say, a shape of or the design of A, then the loop control, and then we went above A, and the whole idea was that as we are looping around, we always gonna go back to A, and we said that's not structured. So the way that we did make structured, we got rid of this line, right? We go back into the loop, and then we added another A. So that's what we mean by this initial statement. Let's say it's A, and then the update statement is the A inside the loop. Okay, so the two relates to each other, and usually it's pretty much the copy of each other. Okay, so when we have a for loop is still going to be a simple while loop. Okay, so let's say when we have a flow chart, right? So we have the loop control, we have the statements, we have the update. Let's do the primer as well. And this is the exit out of it when it becomes false. This is true. And then we look back into the loop. So let's call this A. So we're going to update A. And maybe we're going to have statements, and this is where our logic is. Okay. So how do we implement this? Well, what we need to think about when we're trying to implement this is that you can see that there is A, and then we have logic, and we have update. So it's always the same three components. So when we try to write this in a code, then we're going to be writing as, let's say, while. Let's start with the initial statement, right? So let's say int equals 0, and then we might say while x less than, let's say, 5, and then we create the body of the while loop. Okay. And then within the while loop we do something, and let's say cout hello. Now we do not want to forget the update portion, right? So in this case, x is 0. If we don't update it, it's going to be an infinite loop because we never update the x value. We do not want to go above x to reinitialize it. What we need to do is, within the while loop itself, we might have to say x++. So what is that going to do? Well, x will let us into the loop. Right? So int x equals 0 is A, and then we're using that x in order to determine if we can get into the loop or not, and that's why it's called a loop control variable. And then if we are inside the loop, then before we go and evaluate the expression again, we need to update the same value, and that's why we call it, it's kind of like, we can call it a, let's say, A prime. All right. So it is still A, but it's A prime, which gives us a different x value. So that is, if you look at it, that is one step, right, which is the same thing as this one. Then we have the while statement, which is the same thing as the logic. And then we have the update, which is another A. And the actual statement, what we're going to do inside the loop, is just display hello. So how can we make that simpler? Because we're always going to have A, L, and A prime, which is priming value, the logical expression, and then update to that. Well, the designers actually came up with a simple way of doing this. And that's why they came up with the structure of for loop. And here with the for loop, you have for int x equals 0, and then we put down the semicolon. And after the semicolon, so that is our priming value. Then we say x less than 5, semicolon. So the semicolon separates the three portions, the three parts. And then we have x++ for the update. We still have the body for the for loop, But here in the body, the only thing we need to consider is just the statements. So we can now say cout hello. So now you can see it is the same thing as the while loop, but it's simplified. Instead of what we had is 1, 2, 3, 4, 4 lines of code. Right? Here we only have 2 lines of code. It means the same thing. Okay. So here you can see that it's getting really small, but int equals 0 is A, and then we have the logic, then we have the update, and then we have the statement. So the same code, same performance, but notice that this is a loop controlled, the counter controlled loop. So usually when you have a counter controlled loop, you would use a for loop. If you would have a sentinel or flag controlled loop, we usually use while loops. Okay, so don't get confused. When do I use while loop and when do I use for loop? It's pretty much the same thing, and we use them exactly the same way. Okay, so what you need to look at when you look at a code, okay, you need to design it. You still need to design what the logic is, what the priming value is, and what is the logic for the actual program. So in this particular example, you are outputting hello and the star on a separate line 5 times. And how do we know that it's going to go loop around 5 times? Well, I is equal to 1, and the loop will execute while the I is 1, 2, 3, 4, and also 5. When I goes to 6, it's going to exit. Okay. Now, if we don't put, the key here is to see the body of the loop, right? You can see that just like with the selection statement, so with the selection statements, we have a body of the loop, okay? So it goes from curly bracket to curly bracket, and here we display hello, exclamation, and then in a new line we display the asterisk. Now if you look at the same thing, remember indentation doesn't count in C++. So just because you indent the code, that still means that the for loop only going to consider as its body until it sees the semicolon. So in that case, hello will be displayed 5 times, and then when the loop exits, then you're going to get the asterisk. So in this case, if you want to kind of draw the flow chart for that, right? So what's the priming value? The prime value is I, and then we have the loop logic, right, which is I less than or equal to 5. So when we are inside the loop, okay, we're gonna do an output statement, and basically we have 2 output statements, right? And then we're gonna be updating I, and then we loop around, and then we exit out of the loop. So how does that differ in the second time? So the second time, the second example, let's see. Okay, so in the second example, we do the same thing. So we have the initial statement when we initialize I, then we see if we can go into the loop. Then we have a single output statement. Then we update I, loop back, and when we exit, after we exit, then we have another output statement. Okay? So the output statement comes in here. Hello is executed 5 times. Okay? I equals 1 is the priming. The loop logic goes into the diamond shape, and the update goes into the rectangle. Okay, so that's how it works. It is a totally different program because of those curly brackets. So is everything needs to be or it is required in the for loop, right? Now the for loop requires the 3 components, right? So you separate the 3. So if you don't use the semicolon, then basically the compiler is going to think that you only have one component, one single component instead of 3. So you are required to use the semicolon, but you don't have to fill up all the different values. So can we use the for loop as a while loop? Well, sure. It will not make sense, but you can write a for loop as int x equals 0, and then you say for loop semicolon x less than 5 semicolon, and close the body of the for loop. You can see that there is the 3 components of the for loop. And then in the body, we can do, let's say, cout, and we print out an asterisk, and then we write end of the line, and then we can say x plus plus semicolon, and then close. Okay, that's perfectly fine. It doesn't really make sense, right, that you really taking the priming value and the update out of the for structure, because you really wrote an actual while loop in this case, and you're defeating it, kind of like defeating the purpose of the for loop, to simplify a while syntax. But you can do that. That's perfectly legal, and if you want to, that's perfectly fine. It just doesn't really make sense, so it's not a good programming practice. Okay, so sometimes you don't want to take the prime value up, but maybe you go backwards, right? You can count backwards. So in this case, you can see that you start from 10 and then subtract 1 from the loop control variable in each iteration, and that's perfectly fine. It is based on the design of your code. What is it that you want to accomplish? And you're not required to have just one single value added to the loop control variable, right? So this, when we are updating, the update is an expression. So you can have any kind of update. You can have any kind of arithmetics put into that update portion of the for loop in order to update your loop control variable. It's an expression, so it doesn't have to be always I++ or I dash dash. Okay, It's an expression. You can put anything in there. Now, when we talked about the design of the code, and we talked about structured programming, okay, we only looked at structured programming, that this is a structured program, right? So we have the priming value, we do the statement, we update, and then we look back right after the initial value. And that's perfectly fine. But what does that do? Okay, so if this is my statement right here, the logic will not allow, to execute my statement if the logic results in false. It just automatically takes you out. So is that what you want to accomplish? So sometimes when we're trying to do something, okay, what we have is the statements, okay, the statement, and then we have the priming value. In this case, we can also do the update in the same place. Then we have the logic, and then we loop around. Okay. So why is that different? Why would that still be a structured statement or structured program, even though we did not really? Let's see. This is where the false will take us out, and then true will loop around. So we said that you basically lost points if you left your assignment in this shape, because we said this is not structured. But in reality, okay, this is still structured, because what we called, this is your while loop, okay? So the while loop gives you a pre-test. First you test, and then you decide if the statement is going to be executed. Now in the what we call a do while, what we do is we do the statement first, then we ask if you want to do it again, and then we loop around. Okay, so the shape is a little bit different. So this way you can see, why would you do something like this? Well, if you launched a game, you're starting a game, do you really want to ask the user if you would like to play a game? I mean, that's why I launched the game, right? That's why I started the game. So why don't I just start the game, play at least once, and then after I failed, then ask me, do you want to play it the second time? So the do while loop is a post-test. So we are testing after we at least ran the statements, the body of the loop, at least one time. And that's what this is for. Otherwise, it's the same kind of a structure, but at least it will iterate at least once. Okay. So we're going back to the statement, and the statement is executed. So in this case, you can see you still have the priming value, right? And then we have the statement. Then we update the value, the loop control variable, and then we do the test, right? So this is the priming, this is the expression, this is the update, and there is the logic. Now, one thing you need to consider here, okay, if we have a while loop, okay, if we have a while loop, when we have the expression, okay, you start the body of the while loop and then you finish it. Now with the do while, we start with the keyword do, and then we establish the body of the loop, and then we use the keyword while, then we have the logic, and then we have to put the semicolon at the end. Okay? We did not have to do that with the while loop. Okay? So the while loop is just the parentheses and then the body starts. In the while loop, you have to use the semicolon at the end of the expression. Okay, so make sure that you look at these examples and then you type it in and run it in your compiler. And what I would suggest is that you would run these examples and also stop the code in the iteration and make sure that you understand how everything is updating. Okay, so running the sample code is very important in this chapter, and it's getting more and more important as we move along with the course. Okay, so which loop is the right loop, and which one do we choose? If you know how many times the loop gonna be executing, for loop is the best choice, right? So counter control examples. Let's say you have a game, and in the game you have 3 lives. So that means the game should only execute 3 times. You determine that you have 3 lives. That means it's 3 times iteration. So that's a counter control. Use a for loop. If you cannot determine in advance how many times something gonna be executing, like in Sentinel, right? You can ask a user, do you want to play another game? Do you want to play another game? Do you want to play another game? Right? You don't know how many times the user is going to say yes. In that case, use the while loop. Okay? If you are processing a file, you don't know how many values are in the file. And you might be going for a flag control. You're looking for the end of the file flag. So you don't know where that end of the file is. So that means use the while loop. Okay? If you cannot determine how many times something executes, and you want to execute it at least once, then use a do while loop. Okay? So the break and the continue statements are important because the break will allow you to exit earlier in the loop. Kind of like in the switch structure, what we were looking at in the previous chapter. If you have a switch structure, that's what also happened, right? When you reached a particular statement and you did not want to execute the rest of the statements, we used the keyword break, and those keyword, or that break keyword, actually took you out of that structure, the switch structure. So after the break executes, the program continues with the first statement after the structure. So it's not an exit, it's not a return, okay? It is break out of the current block of code and continue on with the rest of the statements. So continue is used in while, for, and do while structures, and these executed in a loop. It skips the remaining statements and proceeds with the next iteration of the loop. Okay. So let's say we have a prime value, right, and we have a loop. Within the loop, we might have a selection statement, and if the selection is true, we do something. If the selection is false, we do something else. if it is true, okay, then we basically go back into the next value of the iteration. Okay, this is where we would exit out of the loop. So if it is false, we can say break, and the break will take us out of the loop. Okay. So it doesn't matter if we have, let's say we have other statements. We have other statements in the loop. Okay. This way, if you're using, let's say, the continue will disregard, let's call it A. Continue will disregard A and goes into the next iteration. And the break will take you out of the loop and no more iteration needed. And pretty much the last section in this chapter is nested structures. This is going to be very important in our last chapter when we talk about arrays and basically processing arrays. So in the nested loops, what you need to determine is something moves faster, and then after a certain number of iterations, you update the slower processed loop. Now with this asterisk, it's easy to see, and this asterisk example is easy to see, because you can see that whatever we are processing horizontally, horizontal, which means printing out all the asterisk, is the inner loop, right? So first of all, we need to print something out horizontally, and then change line right here because of the end, okay, the end line, and then do it again. So the printing, while you are printing on one line, goes really fast, and then changing the lines goes slower. So what would be another good example for this? Okay, I think the good example would be a clock. Okay, so you have 12, 6, 3, and 9. Okay, and what do we have on a clock? Okay, we have something that shows the seconds. Okay, and then we have something that shows the minutes, and then we have hours. Okay, so what does that mean? How fast does the seconds go? It goes really fast, right? And then the minutes go a little bit slower, and the hours go even slower. So what does that mean? We have a loop. Within the loop, we advance the second, and that is going from 0 to 59. So what happens when the seconds go to 60? Well, then we jump out of this, right? We jump out of this loop, and we jump into the next loop, which will advance the minute loop. So that's when we are going back. So this is the seconds. Seconds go really fast, okay? And the seconds updating goes back into, well, the minutes update, right? This is the minute. When the minutes update, they go back into the seconds, and the seconds starts from the beginning. So the seconds go 0, 1, 2, 3, 4, 5, so forth, go to 51, and the 59. What happens in 59? Minutes update, and now the minute is 1. The minute it goes to 1, we go back to 0 with the seconds, and then the seconds go really, really fast until you get to 59, and 59 minutes update. So then what happens? When minutes go to 59, then the minutes go back to a loop, and that's going to be our hours. Okay? And what happens with the hours? Hours needs to update. And when hours update, then minutes start back from 0. When a minute starts back from 0, the 0 minute starts the inner loop, and the inner loop starts with the seconds. Seconds go very fast, minutes go a little bit slower, and hours go the slowest. So you can see, anytime you have a problem, okay, when you have a problem, then you can see that something repeats over and over again, and that repetition controls a slower repetition, and that slower repetition controls something that even slower than the second one was. That will tell you that this is a nested loop, what's required. Now if the seconds would just iterate from 0 to 59, when it goes back to from 59 to 0, and it would be just independently iterate in an infinite loop. And the minutes would be ticking slower, but independent from the seconds. That would be separate loops. So they're not nested. They would be independent, fast and slow loops. But nested loops mean that one relies on the other. Okay. So so in this case, you have a loop, right? And you start with 5. And in this case, maybe you want to print out 5 asterisk. And after the 5 asterisk, then you control that by removing an I value, and then you remove it to 4. Remove 1 from 5 is 4. And then you would print out the 4 asterisk and 3, 2. And then you go, when I is 1, you print out 1 I value. And at that point, the next value, when you update I, would be 0. And now 0 would be a 0 would give you a false result, right? So in this case, you have the priming value. Priming value is evaluated in the expression. You do whatever you need to do in the body, and then what do? We go back to the update. When the update is done, then we are going through the expression again. Okay, so we might have a lot of bugs in a code, and a piece of a software patch is a piece of code written on top of an existing piece of code. It is intended to fix a bug in the original code. So you make some logical mistakes, eventually find out that your program has some bugs, and then you write a piece of code that fixes that logical mistakes. So that is going to be also why we need to require, why you want to put in comments. Because when you have bugs, you have problems, you might have to go back to the source code and evaluate where you made a mistake and update your code. So you need to understand what the code does, and the way you understand it is by reading the comments. Okay, so loops are harder to debug than sequence and selection structures. So use a loop variant, set of statements that remains true each time the loop body is executed. And most common error associated with loops is the off by 1. So your loop, if the loop is executed 1 extra time, in most cases you would have some kind of error, okay? And it might be easier to detect. Now, if you have 5 items and you only considered 4 of those, it's going to be harder to detect because it's not going to be an error condition. It's just a logical mistake. But usually when we're talking about loops, you're going to have either a plus 1 iteration or minus 1 iteration. So we're going to be off by just 1 when it comes to loops. And that's going to be much harder to detect. Okay? But pretty much that's the whole chapter. Okay? And let me see if we can look at some of the examples, or some example code here. Okay, so usually you would create a project, and like I said, you want to create a driver project or a project that you only use for learning. So that way you can add source code and remove source code from the project much faster. Okay, so we can remove whatever is in our project, and then we can add an existing item. Okay, and let me see if I can find computer science. Okay, let's say okay. So all this code comes with your book, okay, and this way you can load some of these structures. And let's say you want to add the sentinel control. So what does that mean? You can see that the sentinel in this case is an actual value, an actual hard-coded value. And because you have that as a sentinel, that sentinel would not change while the program is running. So it kind of makes sense to make it a constant value. Okay? When it's a constant value, we use all capital letters. So in this case, you have a loop. Okay? You can see the body of the loop is using a while loop. Now the while loop, you need to look at how do we prime the value that we're going to be looking for. And in this case, you can see that this is your loop control variable. All right, so that's your loop control variable. And here we are priming the value, but the value is coming from the user. So then line 4 right here is my statement, or they can be multiple ones, right? Those are the statements. This is what we do within the loop. And then we have the update. Oh no, that's part, sorry. This is also just a statement. Okay, so we have a statement. Why is it a statement and not an update? Because we are not yet updating the loop control variable. Okay, so the update comes from right here. So you can see that whatever the priming value was, the priming statement is pretty much the carbon copy of the update. So this is where we update our value. And because of the update, this is the end of end of the while loop. So you can also put in these kind of comments in your code just to keep it straight if you understand all these different structures of a loop. So if the user types in negative 999, then if we compare the negative 999, it will be equal to what the sentinel is, and that will give us a false result, and that will take us out of the loop and continue on with the loop, or with the application. Okay. So in this case, what you could do is control this and see how the values change and put in a breakpoint in your compiler. That way, before you go into the next iteration, you're going to be able to see the values and how they change. So at that point, you would run this code with the breakpoint set. Okay. You can see that the message is important because the user needs to know, how do I get out of this loop? Okay. So it's not just you asking for an integer, but you're also telling the user in the output message, how do you end? And let's say we type in 56, press enter. Okay. And 67. Okay. So now we have typed in a value right here, and you can see that we typed in 56. At that point, with the 56, we're taking the number is 56, what I typed in. At that point, sum was 0. See, sum was initialized to 0. So what we did, we added 56 to 0, and then we assigned that to sum. And at that point, you can see that the count was incremented. So when the count was incremented, then we asked the user for another value. And that value was 67. Right? So we typed in 67. At this point, number contains 67. But is 67 already added to the running total, the sum? Not yet, right? Why not? Because we're going to add that the next time we iterate. So first, we need to look at what is a number. Number is 67. Does that equal the sentinel? No, it's not. So because it is not, that's what we're looking for. It's not equal the sentinel. So it becomes true. At that point, we're going to go into the loop again, and then we add it back. Or then we are going to add it to the sum. So let's see how that happens. You see the little arrow, we are stopped right here at the end of the loop body. So we haven't gone through the loop again. This is just the first time. So when we click on continue, now we are back into the loop. And now I can type another value, let's say 40. Okay. When I typed in 40, that's where we were stopped with the code. So when I typed in 40, now number is 40. And now we can see that the sum was updated with the previous number. Okay? So at this point, we are still standing right here. This is the second time. You can see that the count value is properly counting how many times we iterate. So this is our second time through the loop. And then we continue on. Okay. right now the window pops up and it's asking for this other number. Okay, and in this point I type in -999. Okay, you can see number is -999. We are standing at the end of the loop. Okay. Let me just put another break over here so we can see when we exit. So now when we continue on, now you can see that this statement on line 27 actually executed because of that -999 value. Now we are exited out of this loop and we continue on with the code. So it's important to read the code, understand the code, and preferably put in your comments into the code, some type of a comment that makes sense to you. Okay? So let's just get rid of most of this right here. Let's see if I have some other example code. Chapter 5. Let me show you this digital clock. Okay, so let's look at this. What does that look like? Okay, so let's just clean it up a little bit. Okay, so let's look at this. Remember we talked about the clock. Okay, what happens with the clock? The second's gonna change a lot, right? So in this case, we start the seconds at 0, and we're gonna go all the way to 59. When seconds become 60, then we're gonna jump out to the minute, and the minute's gonna be updated. So when the minute's gonna reach 59, and then we update 59 to 60, then we're going to jump out to the outer loop, and then we're going to increment the hours. So while we are in the inner loop, that's where we do most of the work. When we do the actual work, what you're going to see is the printing out hours, minutes, and seconds. So within the inner loop, when we are printing out the seconds will change by taking the system to sleep for 1 second. So at that point, you're going to be seeing the second counting, and we are rewriting, redrawing the characters on the screen by not pressing the enter key. So it's not a new line, but what we're going to use, remember the escape sequence? I believe it was in chapter 3, that table. So \R means return but not new line. So we are going back to the beginning of the line, and then we printing out the same message again. Now the interesting thing over here is, look at this, the setW. The setW2 specifies 2 decimal places, or basically 2 character spaces on the screen. And we are filling it with 0. So why would you do that? Because when you display 1, you want to precede the 1 with a 0. Now if you want to proceed with 1 with a 0, you don't want to print a character in front of 0, in front of 1. because when the seconds go to double digits like 10, you're still going to have a 0 in front of it. But in this case, because you're setting the space where you're printing the values to 2, and you're filling the empty space with 0, when we go to 2 digits, it's still just going to overwrite the first digit with whatever value it needs to overwrite with. So that way, when we are looking at the clock, as you guys are going to see, right? So the clock is a value separated by colons, right? So we have hour, minute, second, but the hours need 2 spaces, minutes 2 spaces, seconds 2 spaces. But when I'm writing 1, I'm going to have an empty space in front of it. Well, first of all, in this 2 space, I have to make sure that I'm pushing the output value to the right-hand side of that given space. And I just want to put a 0 in the empty spot. And the same thing with the minutes. I want to put a 0 in the empty spot and then have the minute displayed, and the seconds 0 and then seconds. So it's not a literal value, it is just a filling of the gap. So at that point, we're going to see a nice output. Okay, so we can compile this, and let's just compile it. Okay, it should give us an error message. Okay, just want to show you that the C++ language is evolving and changing, and the language itself also have problems. So because the language also have problems, sometimes they realize that some of the methods, some of the functions are not correct, so they rewrite it, or they might not be secure, or there's just abandoning the project. So in this case, you can see that we have a problem with the underscore sleep method. Okay, you can see that the underscore sleep method is deprecated and is not recommended to be used, but the error message gives you a suggestion what to use. So we should be using a capital sleep method, okay? But the sleep method is undefined. So what we need to do is find out the actual library that has that, and we have it in the Windows library. Okay. So now this squiggly line goes away, so it's not a problem anymore. It finds that method, and because of the method working, the code should be working now. Okay. Do you see that how the seconds updating and the 0 in front of it is not a literal character? We did not print that. That character is printed out because of the set fill method, right? The fill method. So this way, it looks like all the characters standing in place, nicely aligned, and it looks like only the seconds changing. But we know that because of the -R, we are going back to the beginning of this line, and we printing out 00:00:4546. Every single time we go back to the beginning of that line and updating the text, what the user sees. Okay, so hopefully this kind of helps you understand the inner workings of a nested loop. Okay, and again, what you can do is you can put in the breaks for every single one of these loops, and then monitor as the loop are entering and exiting. Monitor each individual variables, and then it's going to make more sense how this works. Okay, so hopefully it was helpful, and like in any other time, if you guys have any question, make sure that you ask those questions on the discussion board, and make sure that you go through all the sample code that comes with your chapter, run it, ask questions about it if something doesn't make sense, and then you should go and work on the assignment. So see you guys next time.